So today we're going to be looking at motion in the plane. Before now, we've done linear motion, where something is moving typically along the x-axis, sometimes along the y-axis, but it's only moving in two directions. Here we can have, you know, um, that it's moving, in two different directions. When I said two directions, I mean two directions along a line. Now it can be moving up and down, it can be moving left and right, all that kind of stuff. And basically, what we're going to do is we're going to use vectors for this so that we can have independent x motion and independent y motion rather than trying to do both at the same time, if that makes sense to you. So if we have a particle that moves along a smooth curve, we'll talk more about smooth curves, I think, a little bit later. Or we did talk about smooth curves earlier when we talked about finding distances. So it has to be differentiable everywhere in order to be called a smooth curve. So its position is x of t, y of t, where x and y are both differentiable functions of t. So the position vector is r of t, and I don't know why they use r, but I don't know why they didn't just use p, is x of t, y of t. V of t is the derivative of x with respect to t and the derivative of y with respect to t, that vector. And by the way, that's why we have these pointy brackets. That means vector. Okay? That may not be the notation that you're used to. What do you use in physics?
We don't put stuff in like a
But like if you're given, you have this vector. What do they, if they give it in component notation, or do they give it?
we do like I and J.
Yeah, it's like that. This is the I motion, this is the J motion. Okay, it's very similar to that. The speed is the magnitude of the velocity vector, which makes sense, right? Speed is just magnitude, no direction. So to find that, we do the Pythagorean theorem. You've done this a bazillion times when you've been doing vectors before. The acceleration vector is the second derivative of position with respect to time, both for the x and for the y. They don't ask for number 5 very often, but I think that's something that may start coming up more because displacement as a term used to not be anywhere in the BC curriculum, and now it is. So the displacement vector from time t is equal to a to time t is equal to b is just going to be, this is going to give you the change in x, and this is going to give you the change in y. So that gives you your displacement vector. You can also find from that, you could find the, we can find the distance traveled. Now the distance traveled, remember we did arc length in our last lesson, right, for parametrics? This is just parametric arc length. That's the distance that it's going to travel. It's really the same thing. The vector part of this, I always kind of struggle with, well, how different is this? It's really not that different from parametric. People sometimes treat it like it's this whole new thing, and I'm like, it's not really. Okay? So, let's take a look at this example. A particle moves so that its position at any time t greater than 0 is given by 4 sine of t, 2 sine of t. Find the particle's velocity, acceleration, speed, and direction of motion at t is equal to pi over 4. Direction of motion, you notice, wasn't something that was up there. We'll talk about how to do that in just a second. So let's find the velocity vector. So the velocity, v of t, is going to be 4 cosine t, 2 cosine t. So at pi over 4, since pi over 4 is the square root of 2 over 2, this will be 2 square root of 2, comma, square root of 2. Then the acceleration, we'll take the derivative again. This will be negative 4 sine of t and negative 2 sine of t. So the acceleration vector at pi over 4 is going to be negative 2 square root of 2 and negative square root of 2. The speed at t is equal to pi over 4 is going to be equal to the square root of 2 square root of 2 squared plus the square root of 2 squared. 2 square root of 2 squared will be 4 times 2 is 8. The square root of 2 squared is 2 by definition. So the speed is the square root of 10. Now, the direction of motion, so what we're looking at then is, all right, so we've got a velocity, and that's going to tell you the direction of the motion. So what we need to look at then is we've got something that is, its vector for velocity is given here. So we know that tangent of theta is going to be the y-coordinate over the x-coordinate. You've done that before, yes? Is equal to a half. So the direction of motion is going to be theta is equal to the tangent inverse of 1/2. Whatever the heck that comes out to be. So basically that tells you at what angle from the positive x-axis is this thing moving. All right. So let's do this one. Particle moves in the plane with position vector r of t is sine 3t cosine 5t. Find the particle's velocity and acceleration vectors and the length of the path from 0 to 2 pi. All right, so v of t is going to be 3 cosine 3t, comma, negative 5 sine 5t. So, oh, and it just asks you for the vector. Okay, so then the acceleration vector, a of t, is going to be negative 9 sine 3t, negative 25 cosine 5t. And then the length of the path is just going to be, sine and cosine are both going to be differentiable everywhere. So we have a smooth curve here. So the length of the path will be the integral from 0 to 2 pi of the square root of sine of 3t quantity squared. Oh, excuse me. My fault. I accidentally looked at the wrong one. So the velocity vector. All right, so if we go back. to here. Distance traveled is the magnitude of the velocity vector. And we integrate that. So this is going to be 3 cosine 3t quantity squared plus 5, I guess I should put in the negative, although it's not going to matter because we're going to square it, 5 sine of 5t squared dt. There are ways to do things like that, but it's typically, it's not something that the AP exam is going to ask you about. So at that point, we'll just grab a calculator and go, okie dokie. So a little math 9 action from 0 to 2 pi. Of the square root of the quantity 3 cosine 3t Oh, interesting, because I still have it in parametric mode, it automatically uses t. Not that it really matters. So I need to make sure to close both those parentheses before I square it. Plus, and I am going to not bother putting it in the negative because, well, it doesn't matter. I'm squaring it. Close both those parentheses, squared with respect to t. Still thinking. Wow, that's thinking a really, really long time. So if something like this happens on the AP exam, don't sit and watch the lines go by for 2 minutes or whatever. Just go on to the next problem and let it, cogitate for a while. So it's 24.603. Sometimes when you put in something and it takes a really long time, you begin to wonder, uh-oh, is this something that's actually impossible to do? Try not to panic. Because you start to get this panicky feeling like, uh-oh, if I screwed something up, and sometimes you have and sometimes you haven't. All right? Any questions about that? Okie dokie.